So this is the second question on your mock paper, which was the Jan 2013 M1 paper. Should say something about time at this point. Remember that the M1 papers, well, the AS papers are very different to GCSE. Quite a few of you never had any problem at all with timings in GCSE, but in A level you really have to watch the clock and have to plan your time carefully so that you don't miss out on the last few questions. If you run out of time and don't do a question at the end which is worth 10 marks, well, that's 10 marks out of 70. So you can work out what kind of percentage that is and what kind of grade you've just lost there. So always keep on target, always keep an eye on what you've got to do. One piece of advice I would give you is to read every question very quickly at the beginning and maybe allocate a time budget and try and stick to that where you can. Okay, so question 2. A particle P moves in a straight line. The displacement of P from a fixed point on the line in meters is given by that formula there, and where T is in seconds. Show that when T equals 1.5, P is instantaneously at rest. So what we've got here then, we've got an object on a plane, on a line P, and S is defined where S is displacement, T to the 4 minus tt cubed plus 5, and that's given in meters. Okay, and we've got to show that when T equals 1.5, P is at instantaneous rest, and it's worth 3 marks. Now the word show is important in this question. Show. All we have to do is, we can solve an equation, but we don't have to. We can just use a substitution. So what we need to do is find V. Now V is equal to the displacement of P. Now I've called it S there. Quite a few of you prefer to see it written as X, so I'm going to write it as X, but it is S or X, but that's what we probably see more often in class. So that's dx by dt. It's the first differential. Okay, it's the gradient of this distance time graph, and to work out the gradient then you have to differentiate. So we're going to differentiate x with respect to time, and then we're going to substitute 1.5 in, and then that should give us 0. So I'm going to show that v equals 0 when t equals 1.5. So I've written that, so before I start doing any of the maths, the examiner is aware of what I'm intending to do. Right, so now we're going to differentiate that function. So dx by dt is equal to 4t cubed minus 6t squared. Okay. And remember, back to your core 1, you should be good at differentiating, and from class I remember you are. Now we're going to substitute when t equals 1.5, and we get 4 lots of 1.5 cubed minus 6 lots of 1.5 squared, and they're going to work out what that is equal to. And that does equal 0. So we know that particle P is instantaneously at rest, is at instantaneous rest when t equals 1.5 seconds. Now if that was find at what time particle P is at instantaneous rest, then we can solve this equation and find out when it equals 0. But we can save a bit of time because we're given that time and we're asked to show that it does. And again, it comes back to that time budget I talked about at the beginning of this video. If you look for the quickest way of getting to the correct answer, you can save time for the later questions. Now the next question, part 2, it's also worth 3 marks, is to ask to find the acceleration of P at 9 meters. Show the acceleration of P, so is 9 meters per second. Now we know the second differential is equal to the first differential of dv by dt, and that is equal to a. So basically we've got to differentiate again to get a. So the second differential of x, or the first differential of v, will give us the acceleration. because the acceleration is the gradient of the velocity time graph. So now we're differentiating again. So we get 12t squared minus 12t. And we're going to find out show that that equals 9 when t equals 1.5. So again, we substitute it carefully in showing our workings clearly, nice and neatly, so the examiner can read it, make their job easier, and then we work out the answer. And it is 9 meters per second squared. So that's a nice question. It's a nice question because it was a show that question, so it's quite quick. What they're testing there is that you understand the relationship between displacement, velocity and acceleration when acceleration is not constant, as it is in this case. And it's 6 marks, so it's something you have to get right. But the nice thing about this as well is you knew you're right, so it builds confidence and it helps you settle the nerves for the next question. So it might have been something you wanted to do first before you even did question 1, because you don't have to do them in the same order. You have to use the booklets correctly, but you don't have to do them in the order that they're written. So sometimes find a question which you're confident in, and that might settle your nerves. Okay, question 3 should be available on the same playlist.